I was walking in his class.
I don't know. I know it smells.
Yeah.
I'm not sure why it smells, but I'm assuming that's why the boys' bathroom is locked.
Yeah, it's like sewer.
Because of the smell.
I would assume it's like sewer.
I mean, at first I was like, well, you know, sometimes the science building just smells because, you know,
Yeah, it's a science building.
chemistry, gases, sometimes the pipes back up or something.
Yeah.
But apparently it was more than the typical weird smells in science building.
Did somebody come and tell y'all?
No, actually, Jordan told me.
Good
That
job.
it was closed.
You're a good student.
Yeah.
That was the first time I heard of it. But I mean, I smelled it this morning.
My thing was that like I didn't know
Oh.
because you were standing right there in the middle of the hallway. I was like, I'm gonna ask him later.
I got 9% class. I got 9%. My project when it is quarter. Oh, I
The project I didn't know. I told you what, right? You just
Didn't you mess up the car?
no. See, they go fast. He started doing. Okay, the car does not matter.
Hey, Dylan, you could have got points.
What you had to win? You got points to win for get out. And where you working hard? Where you trying to win? Waste? No, he's still trying to add waste to win. What?
Alrighty, folks. I checked all notes. Did I miss anybody for notes? Sold. Last chance to answer our dollar question while I give you our dad joke, which doesn't ask a question. It just says campers. Mother Nature's way of feeding the mosquitoes.
What's the question?
Campers are Mother Nature's way of feeding the mosquitoes.
The mosquitoes bite the campers. Yeah.
That's really.
It's not really
Yeah, it's not funny.
It's just
It's
real.
more like an inside joke.
It's kind of just a real statement.
Yeah.
It should have been like, why do campers hate mosquitoes?
Let me start up our test for the makeup testers here.
Can there be more than one answer?
Here?
Yes.
No.
Well, since they're all different,
No.
they're all different answers.
Zero.
Yep.
I don't know what answer is this man.
Not algebra. I might answer.
I know pregunta, but I don't know.
Pregunta.
Muy bien.
Well, I don't know what answer this is.
Answer?
Oh, it's B.
Respuesta. There we
It's either
go.
B, A, or C.
I said
Well, that's
It's either A, B, or C.
after.
Oh, respuesta
I
es.
think no one's copying me.
Say what?
I don't know. Wow. Alright, hold on guys, let me start this.
Bro, you're the goat.
We know you can.
Oh shoot. What's that game called again?
Prodigy. I forgot about it, and my friend told me. I was thinking about it.
Where you taking us?
That game. And they were like, Prodigy. I was like, you know what? I had
You think there's Prodigy for AP Physics?
Huh?
You think there's Prodigy for
No,
AP
it's
Physics?
English now.
Oh.
I chose first grade math though.
What you
I chose first
Oh,
grade.
Mr. Maynard,
Yo.
I have another question.
Another question.
Because I love bothering you.
I agree.
You're not supposed to say that. Is there any chance that like whenever you have the study guide that you can give it to us like earlier? So we have more time to do the study guide?
I will keep that in mind.
Yeah.
Aw, you're such a considerate teacher. Most teachers would have been like,
Because the
don't
only problem that I ever have when
What
it
if you
comes
don't
to
read?
I think sports
I'm not gonna do it
I
anyway.
have a harder time trying to fit that in like everything else. But like, I feel like the more time I have, the more time I can break it up and really look at it.
I will keep that in mind.
I'm not gonna do it, but I have no time to think about it.
Remind of that.
Exactly. I don't be in there for a while. I'm gonna pull it out for one day and do like 3 questions.
Remind me.
I'm ready for this.
Resolve again.
I'm already ready for
Yeah. Alright, let's take a look at the answers here.
They took my gems.
All right, you're in there.
So, your gems.
I chose first grade math. I'm doing the story.
I'm put all these videos on.
Alright, we're looking at your answers.
That's really smart.
But just for me.
So just gonna So might as well just keep it in your damn phone.
No, it's dude, like one video is 10 gigabytes. It's a lot. Yeah. My phone takes a lot of very high quality.
Oh, I remember that guy. Yo, where's that big dragon? Bro? I remember
This is my land school screen. If you haven't seen that yet.
The new what?
My land school
I
screen.
used to spam it.
Wait, let me see. I actually want to see it.
No, you know what I used to do? Well, we should have a little
Look
Asian
at all
guy.
that.
That looks
I used to hit him
scary.
with the
Jordan Edwards is
You
playing
can't beat me
game
in
today.
I could beat you.
I'm not
Jordan,
playing
they're
a game.
sneaky.
Huh?
Spying on you, dude.
Oh.
Oh, what's up? My prodigy.
You see my grades? While you're in there, look at my grades. You see the zeros for the pods?
You should just change those.
Alright, Bradley, you up yet?
Prodigy out there.
What?
For real, you watching me play prodigy.
Ah, there it is.
No,
Let me pull up something.
What? Yeah.
I am stupid.
Oh, this is one though.
You failed
It's
first
like
grade
screen
math.
inception.
You stupid.
It says,
Bro, how do you fit?
so
Oh,
you
number
guys
lines?
are on the
I did not
screen,
do
and it's
that.
mirroring my screen. So it's like,
I chose first grade math. I still got it wrong.
Alright,
I know,
Bradley,
first grade
you
math.
should start so I can.
Chose first
proceed.
grade math. and I still got it wrong.
The same one? Yeah, same link.
Algebra 2.
Alright, looks like we got D.
Yeah.
There's no D answer.
Oh my god.
Wait.
There's no crying in baseball. I don't call it
Is
that.
there a me in D? I'm so sad. I honestly feel so stupid.
You're game, bro. You're game. Bottom.
Okie dokie. D.
Damn, that shit hit me hard.
Do you know where that quote is from?
Which quote?
There's no crying in baseball.
That's from Sandlot, right?
No.
No, it's not.
Black phone?
Actually, a little
Wait,
younger than that. What?
A League of Their Own.
A League of Their Own, yes.
I thought
So
it was Black
there
Phone.
is a Capital One commercial out that's kind of copying that, but it originally came from a 1990s movie
You chose the
called The League of Their Own. So yeah, where Tom Hanks is the coach. It's like
That's me.
World War II.
Yeah.
And so the men are all off in the army fighting. And so they still want to do baseball, so they get this women's baseball league up and running. And it's hilarious. It definitely has some inappropriate parts, but for the most part, it is pretty decent. But there's one part in the game where Tom Hanks is yelling at his player, and she's crying, right? She's like bawling her eyes out because I'm not sure what happened. But he says, "Are you crying? There's no crying in baseball." But he says it, you know, as he's yelling at her, whereas the commercial is much more lighthearted. So,
What's your favorite movie?
Star Wars.
Which one?
I like the original 3,
Okay.
to be honest.
Star Wars
Yeah.
Force Awakens was the only good one in that trilogy. The other two are terrible. Oh my god.
Yeah, and I have mixed opinions about the prequels and the sequels. I like Rogue One a lot too. Like
don't like
in terms of like a standalone movie, yes, there's a lot of people that die in the end, but you know what? It was a good movie. And it was the first one that actually showed droids like having attitude, which was fantastic. I love A2SO, so
Yeah.
good stuff. If you've never seen Star Wars at all, you gotta start at least the first time you see them in release date, not according to the number of the episodes, because it starts with 4, 5, and 6, then it goes back to 1, 2, and 3, and then 7, 8, 9, and then there's the Rogue One movie and the Solo, which aren't actually episodes, but they'll fit in there. But because the original movies were made in the 70s and 80s, like the acting and the sci-fi effects are definitely not the same as they are, especially the lightsaber battles in the very first movie. If you watch the more recent ones and then you go back and you watch the original one, you're like, this is lame. So you gotta start off with the first ones and then work your way. But then once you've seen them all, at least the movies wise, then you can go back and like watch them in chronological order so that you fit the pieces of the story together.
My cousin used to force me to watch them. By
Yes.
force, I mean I like watching them, but like he never
Force
did
you
like,
to
in
watch
good
it?
order. What?
Force you to watch it?
Oh.
Wow, that was so funny. You're hilarious. That's so funny. You.
But he never did it in like the good order, so I was always confused, and I've never gone back through and like did it in the right order.
Gotcha. Yeah, if you are a hardcore, like you want to see every single thing happening, you better have a Disney Plus account because there's shows that will fit into the holes of the story as well. Like there's 7 seasons of the Clone Wars, which is a cartoon, which fills in the gap between episodes 2 and 3, and then there's the Bad Batch, which takes it from episode 3 and kind of continues, and
Mandalorian.
Mando, yeah, it's
That's a lot.
it is a
No,
lot.
Acolyte, the new one.
It is a lot.
They
Yes.
just keep going and going.
I like the new one. The new show's good.
The new which
The
show?
Acolyte one. It was like released in the summer.
Transformers.
The Acolyte.
Yeah.
So I'm watching that right now. There are a lot of people who don't like it.
Are you one of
I
those?
just don't like Star Wars.
Dude, this one Sith, he like.
I don't not
Jedi,
like it.
and he won.
Just because of what other people are saying though.
Yeah.
Like I have my own
So you
opinions.
can go tell
I
other
mean,
people, bro.
overall,
It
it's
was
a
so
decent
tough.
story.
It was so
Yeah.
tough. Yeah, go run it back.
But I'm not done yet, so
Yeah.
the jury is still out. Watch it.
For the Clone Wars, my dad was rewatching every Star Wars movie in chronological order.
Yep.
Show, and I had to sit there and watch every single season with him.
Wow.
And the animation is terrible.
Well, they were going for a particular look too, so.
Yeah, I wasn't a fan.
Oh, dude, I used to be so happy when I see that correcting. I was like,
Yes.
I forgot how like Prodigy worked.
Yes.
I'm not gonna lie.
How did not get
Yes.
sued by Pokemon?
Because it's not Pokemon, it's not
Time to go home.
Correct.
You gotta have the sound effects.
Okay, enough about Star Wars. Let's get back to real physics here.
Oh, I missed Star Wars.
Sorry. Alright, so we got some A's and a D and a C in there. Good, yeah. Anyway, so we're talking now about circular motion and rotational motion. Okay, so we're gonna take what we know about translational motion, which we haven't really labeled it as such, but the motion that we've already talked about, moving through space, that's translational motion, as opposed to rotational motion, which we're really not going anywhere in the grand scheme of things. We're just spinning in place or moving in a circle, but overall, we're not going anywhere. So when they say a rigid body, this is a rigid body, as in there are no pieces that can slide or shift as it's moving, but it all moves as one big unit.
Will it
Okay?
ever
Of
stop
course,
moving?
it's allowed to spin, but there we go. Huh?
Will it ever stop moving? Will it ever stop moving?
Yeah.
It doesn't look like it.
Looks like it's gonna keep going.
Well,
It's slowing down.
it will slow down and eventually stop, but I mean,
10 minutes later.
not let it go that long.
Where's
So,
the battery?
a rigid body is rotating counterclockwise. If we look at the clock here, the clock hands are going to go like this. So this would be clockwise. So we're talking about counterclockwise rotation. Make sure that we're all on the same page in terms of which way it's spinning. Okay. So each one of these pairs is an initial angular position and a final angular position. Well, what's angular position? If we're talking about motion in a circle, we know that a circle is a set of points equidistant from the center, so we're going to park our circle on the xy plane. And the angular position. Now, we've learned a lot about translational motion, like position, velocity, acceleration, etc. And we're going to see a what's the right word? Correlation, that's really not the right word, but we're just gonna go with it. Anyway, so we've got our translational motion and things that we can talk about, and we've got our rotational, which we may also call angular, okay? So in our translational sense, we've got our position or our displacement, which technically we use S as both of those. So for the angular position, we're going to use theta, which is typically used for the angle, okay? So as we track where on the circle we are, just like you can kind of see based on where these flags are. So initially, it might be right here, but after a certain amount of time, it's right here. So we can see that there's a change in the angular position here. So if we start off here, so this is our certain angular position, let's call it theta initial, and then after a certain amount of time, it's here. So the new angular position is going to be that. Keep in mind that we are going to measure our angles like we usually do from the positive x-axis, and we're going counterclockwise in our positive angles. If we go clockwise down, those would be negative angles. Okay, cool. There's something else that I forgot to mention, but I think we're going to cover it in a different lesson. So never mind. I'm just talking to myself aloud. So you're wrong. Moving on. Now when we talk about our units here, so the units for our displacement would be in meters, but the angular displacement will be in radians. So typically, so far whenever we talk about angles, we say the angles are in degrees, but we're going to express these guys in radians, okay? So the angular position or the angular displacement, which would be the change in our position here, is going to be in terms of radians. Now, I can say radians, but I don't actually have to write it. It is inferred. Just like when I write x, there's an imaginary 1 as a coefficient, but I don't have to write the 1 in there. I know that that is 1x, okay?
If you got this, my message to Mr. Kaufman said to not write radian, just rad, because it means a different physics. Is that like, I don't know.
No, it's the same.
Same?
Yep.
Okay, because he was making us write up pi r, or not pi radians instead of pi rad. He said we have to write it radians.
I don't know what else it would stand. Oh, hold on.
I'm an algebra. I don't know.
He might be talking about some sort of yeah, I don't know. At least not anything that we've covered in honors or AP or IB physics in the last 18 years. So, yeah, feel free to call it so we are going to say radians, but we don't actually have to write it, okay? So, so let's get back to our question here. So, which of these sets which of these sets of angles can occur only if the rigid body rotates through more than 180 degrees? So here we are given degrees, but our answers are expressed in radians. We need to know how to convert. Do you know your conversion?
Yes.
I know what it is.
Pi radians is equal to 180 degrees. So whichever one you're trying to go from and to, which one will go on top changes, okay? But we do know that this is the relationship here. So pi radians is equal to 180 degrees. And we know that pi stands for 3.1, blah, 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 blah. You don't need to know all of the,
You're making it up.
wow, that's impressive. Unfortunately, that's not going to help in this class.
Yeah.
So.
Or it's
So, for all practical purposes, in terms of this problem, we are going to estimate that our pi is just 3.1. So, we're finding what is the displacement, or what is the change in their initial angular positions as we go from one to the other, and it has to be more than 3.1. Okay, so as we look at A, and all, or a lot of you guys chose A, the difference between 3 and 6, that's only 3 radians. 3 is less than 3.1, so that's not it. Sorry. B has a difference of 2 radians, which is definitely not more. C has a difference of 4. 4 is more than 3.1.
Nope.
C is the correct answer. Yes. And I think guys, oh well, D is not a possibility. So sorry guys. Let's. Sorry guys. Bit too late, but having. Where's my? Here we go. My pencil.
What?
There's no way like you were like digging somewhere and you found pot. Like you made it up.
For A. This is less than 2.8. Here we go. And we've got the mutant maniacs. The only ones who got the color correct. Good job. Okay, here we go. So, as we continue, we are going to look at our equation sheets here in just a few minutes. Okay, but let's kind of keep going with our translational and our rotational comparison here. So we know that the rate of change of position gives us
Displacement.
the rate of change of, so remember the rate of change of something is the change of it over time.
Acceleration.
So our displacement over time gives me
Acceleration.
velocity. Yes.
It's been a long time.
It's been a couple of days.
It's been a while, so I went off a lot.
So remember our units are meters per second. So we've got an angular velocity as well. So if we take our angular displacement and divide it by time, that's going to give us our angular velocity. Kind of looks like a W. That's actually the Greek letter omega.
Why?
Omega.
Why?
It is lowercase omega. You are correct. Because uppercase looks like that. So that is its lowercase counterpart. Now you might be wondering, well, they don't look the same. Neither does that. Those aren't the same symbol either, but we know that both of them say the ah sound.
That's O for omega school.
Oh, yeah, yeah. So these say the O sound in Greek.
Oh.
And we'll actually talk about a couple more Greek letters here for our time today. All right, so let's take a look. So we've got radians per second in terms of units. So I'm going to say radians per second, but I'm going to write 1 over seconds. Because I write nothing up here for the radians, and I'm going to write that, or I can express it in IV units s to the minus 1 half. Okay? Likewise, we also have, so if we've got displacement and velocity, what's next? Acceleration, there we go. So remember, acceleration is the change of the velocity with respect to time. So here we've got angular acceleration, which we're going to call alpha, another Greek letter. There you go. And this is going to be the rate of change of the angular velocity. There we go. And those units will be, so I'm going to say it as?
Oh, you're looking for answers.
Oh,
Yes.
Okay.
Radians
You have to write it rad. Oh,
Per.
huh?
Per second.
per second
Square.
There we go. So I'm going to say radians per second squared, but I'm going to write 1 over s squared, or s to the minus 2 power. There you go. Okay, cool. So we've got the translational system and the rotational system. We will learn in a future lesson about how the kinematic equations will transfer over as well, but we're going to save that for another day. Okay? So, assuming that this is going to spin, let's say at a constant rate, then the angular velocity is going to be constant. However, if it changes, if I speed it up, then the angular velocity or the rotational rate is going to increase. And then as I slow it down, that was rough, then it's going to decrease naturally. Now, we'll talk about the directions in another lesson as well. Let's just get down the basics first of all. Okay, so as we have an object going around in a circular path here, it's going to change its positions with respect to time. Something that I talked about with the other classes is that, so the positions, this is almost like the polar coordinate system. Most likely you've never heard of the polar coordinate system. They used to teach it in like the pre-calc classes. I'm not sure that they still do. But basically, it's kind of like if we were to take the basic, okay, well, this is a point on our circle, which we typically say is, you know, x, y. We know how to plot our points. That's the rectangular coordinate system, okay? But especially as we have something going in a circular path, the x's and y's are constantly changing. So it's kind of difficult to write motion equations for these things which are constantly changing. So it's much easier to express it in polar form, which you really kind of already know about that, because the polar form is going to tell you, okay, well, the point is a certain distance r away from the origin, and it's pointing at an angle theta with respect to the positive x-axis. So the polar coordinate is really r theta. But we already know kind of how to translate between the x's and y's and the r's and thetas, because we know how to break up a two-dimensional vector into its two components using my sines and cosines. And then we know how to stick them back together again. So we kind of already know those skills, we just didn't know what it was actually called. So whenever you do learn about polar coordinates, you'll be like, ah, Mr. Reader, show me this. I already know this. Bonus. Yes. Okay, cool. So let's continue. Where's my book? Making sure that I cover all of the necessary things. We've got a lot of new equations, although not all of the equations are in the A2 section in our book here. Or I'm sorry, A2 section of our data booklets. Okay, but we are at the bottom of our A2. Let me go back to the right pages, because I was looking at another class. Goodness, no, come on, A2. 74-ish. There we go.
7, 8.
Okie dokie. Cool. So, I think that's all that we needed to do about that. Let's transition. Oh, no, there's one more thing. So there is a connection between the angular speed omega and the translational speed v. So if you were to look at the two flags here, we've got the yellow and we've got the orange, and as this spins at a constant speed. Now, notice that this is a rigid object, so all of the things on the object are experiencing the same angular motion. Okay? So the same angular displacement, the same angular velocity, the same angular acceleration. Okay? But if we were to say, okay, well, how fast are they going with respect to the ground? Well, then that would be the translational v that we're talking about. Okay? And if you notice, if you were to track which one is going faster around the circle, or in terms of on the ground speed, the orange or the yellow? Orange, yeah, because the orange is covering more distance in the same amount of time that the yellow one is, because it's on a bigger circle. The yellow one is on a smaller circle, and the circumference of the bigger one, well, it covers more distance in the same amount of time, so it's going faster. So we see that the main thing here is how far we are away from the center. What is the radius? And that is really the linking key here between the translational speed v and our angular speed omega. V is equal to r times omega. Yes. So all three of these will actually translate like that, but that's going to be the one that we use the most. Okay, and the units even work out the same too, because we've got a meters per second for the velocity, we've got our radius, which is in meters, and our angular speed in radians per second. The units work out. Look at that, amazing, very cool. So we'll use that here in a few minutes as well. So now let's transition to looking at, well, let's just try to focus on the object like the orange flag as it goes around in a circular path, just like if we were to have like a car going around a circular, yeah, that's fine. A car going around a circular track, or a ball on a string going in a circular fashion. So let's kind of switch gears here. That pun was definitely intended. Thank you, thank you. I'll be here all day. Yes, because gears spin, they rotate.
Does it, when you were talking?
But you gotta press the clutch, or else you're gonna mess up your transmission. We're talking annual transmission, which is really uncommon these days. But it is definitely useful. If you can ever find a person that has a stick shift car, it's definitely useful to know, just in case, you know, the world ends and you have to drive like an old car and you don't know how it works.
What?
Where would you travel?
I wonder when the world would end, guys.
That's a good question. Some people said it was 2012, or way back in the year 2000, like when the clocks turned over, Y2K, that was big.
It's gonna happen tomorrow.
I don't even know what went on
prediction.
during
My guess
that.
is
Like, I don't even know
2032.
the story.
2032, April
So
8th.
long story short, we were all concerned about the banks and the numbers and the computer programs, because before the year 2000, we only did our dates as 2 digits. And so when the new, going from 1999 to the year 2000, it would go from a year 99 to a year 0. So we didn't know like what would happen with like bank programs and things like that.
You guys never simulated it?
Y'all are slow.
They never simulated it?
Y'all are
I
just-
bet you can I can change my time here.
It was the 90s, yes.
I think y'all were really just.
So
They were high.
basically there was this big old like, what's gonna happen, planes are gonna crash, the world's going to end, blah, blah, blah.